Here are the answers to numbers 9 and 10 on the momentum review paper. A truck weighs 4 times as much as a car. So mass of truck equals 4 times mass of car. If the truck coasts into the car at a speed of 3.3 meters per second and they stick together, that's an inelastic collision, what is their final velocity? So we're just going to look at our conservation of momentum. Initially, the truck is going to have momentum because it's moving. The car is not because it's just sitting there. The momentum of the truck and the momentum of the car after the collision are what's on the right side, and they're both moving, so they're both going to have momentum. So simplified, that equation is going to be momentum of the truck equals momentum of the truck after the collision plus momentum of the car after the collision. Putting in mv everywhere we have momentum, or p, I get mass of truck times velocity of the truck equals mass of truck velocity prime plus mass of car velocity prime. These are both the same velocity because they stick together. I'm going to replace mass of truck with 4 times mass of car. The reason for that is I have too many variables here. I know the velocity of the truck, and I'm trying to find the velocity prime, but I don't know mass of truck, I don't know mass of car. It's going to give me too many variables. I can't solve for that. So what I'm going to do is I'm going to plug in, wherever I see mass of truck, I'm going to plug in 4 mass of car, because that's how much mass the truck has, 4 times the mass of the car. So instead of mass of truck, I'm going to put 4 mass of car times velocity of the truck equals, instead of mass of the truck, 4 mass of the car times v prime plus mass of the car v prime. On my left side, I get 4 times the mass of the car multiplied by the velocity of the truck equals 4 mc v prime plus another mc v prime is 5 of them. 5 mass of the car times velocity prime, velocity of the two as they move off together. I can simplify. If I divide over this 5 mc to my left side, the 5 is in the denominator and the masses of the car cancel out, leaving me with 4/5 times the velocity of the truck equals v prime. That's what I just get in this line right here. I can plug in my velocity of the truck, which is 3.3 meters per second, so I know the speed that they're going to move off with is going to be 4/5 times the initial speed of the truck, which is 3.3 meters per second. So I know they're going to move off with a speed of 2.64 meters per second. Number 10. A 55 kilogram swimmer is standing on a stationary 210 kilogram floating raft. The swimmer then runs off the raft horizontally with a speed of 4.6 meters per second relative to the shore. So they're running sort of off this raft into the pool or the shore or whatever. We're going to find the recoil velocity, or how fast the raft goes, as a result of this person running off of the raft. So we're going to do conservation of momentum. Initially, you're going to have momentum of the swimmer, momentum of the raft equals momentum of the swimmer after plus momentum of the raft after. Now these two things, the person is just standing on the raft, so they are not moving. They're just sitting next to each other. They're on top of each other. So the initial momentum on this left side is 0. They're not going anywhere, which means that the momentum of the swimmer after he runs is going to be equal to the momentum of the raft after he runs off of it. Whatever momentum he gains has to come from the raft. So if he gains momentum to the right, the raft is going to get pushed back and gain momentum to the left, equal amounts. So that's going to be mass of the swimmer multiplied by the velocity of the swimmer prime equals mass of the raft times velocity of the raft prime. I'm solving for the velocity of the raft after he runs off of there. So I just have to divide by the mass of the raft, which is why it's in the denominator now over here in this step. I can plug in my numbers. Mass of the swimmer was 55 kilograms times his speed, which is 4.6 meters per second. Divide that by the mass of the raft, which is 210 kilograms, and I get how fast the raft is going after he runs off of it, which is 1.2 meters per second.